Hi, welcome back to Leetcode. So in this video, I am going to discuss the second problem from today's biweekly contest 165. The problem name is minimum discards to balance inventory. So you are given two integers w and m. So and an integer array arrivals. Okay, where arrivals I is the type of item arriving on day I. So days are one indexed. Okay, so in items are managed according to the following rules. Each arrival may be kept or discarded. An item may only be discarded on its arrival day. So what about decision that we have to take only on the arrival day, right? We have to discard or we have to keep this. So for each day I consider the window of days. So max of 1 to I minus w plus 1 or I. So the W is the most recent days up to day I. So for any such window, each type item may be appear at most m times among kept arrivals whose arrival day lies in that window. If keeping the arrival on day I would cause its type to appear more than m times in the window, that arrival must be discarded. Okay, return the minimum number of arrivals to be discarded so that W day window contains at most m occurrence of each type. So that means suppose for this example 1, what they are trying to say that we actually have one input array arrivals that indicates that each ith index, it indicates that ith index, that means the day. In ith day, what type of item it's coming, right? Now we have to take one decision that either it will be kept in our list or it will be discarded, right? And we have to check that whatever actually window length w, suppose this is our window length, here w is 4, that means suppose the current is the ith day here, so we have to check only the ith minus 1, I minus 2, I minus 3. So latest or the last 4 days we have to check that within this window, we have to check that whatever the actual type actually is present, whatever type, it may be possible that first I minus 3 that day we actually have suppose x1 type, then actually we have x2 type, again x1, it may be possible that same actually type is present, actually it is actually x2 again. So it's mean within this window the last 4 days we actually have x1 is present 2 times, x2 is present also 2 times, and suppose we actually have one, we will get one m value. They have mentioned that what are the condition is that what are actually the number is present or what are the type of actually what are the frequency of each type, it should be less than equal to m. Okay, that means x1 is less than equal to m, x2 also less than equal to m. x2 means the frequency of, it will be better to say that the frequency, correct, frequency, not the number. So frequency of x1 it should be less than equal to m, similarly for frequency of x2 it should be less than equal to m. So if it is both actually true, then we can say that this window is valid. So we can actually keep this item ith day, whatever actually the item is coming x2, that we can actually store that, keep that. If suppose we got one, our frequency of x2 so greater than m, then what actually I have to do, I have to discard this current item. So that time I have to check that what is the number of discard actually I have done. So this will be increase the frequency or like the discarded item by 1 because I am discarding the current element, what is actually coming in the ith day. Clear? You just observe the statement very carefully. Okay, so if it is greater than m, so I'll discard that. So that means this number will not be present in the window. Now next I go to the next day. Suppose previously this was the last 4 days. Okay, now that means next is it was the ith day. Now this will be I plus 1. So now it will be added. Just observe that how actually it is using the sliding window here. If you just follow the actual diagram, then it will be easy to understand how it is using the sliding window. So now for the next step, I will adding the new item will arrive at the I plus 1th day, right? This is clear. Suppose I got x3, okay, but our window length is what? W. Here actually W is 4, correct? W is 4. That means this, what are the latest 4 days actually I have. This was the one, this is the one, this is the one, this is the one. This 4 actually the latest or the last 4 days, right? Then you can just see that this day is going to discard it from our window, like it will be actually out of our window, right? So that actually I will adjust that. So I'll check that. Now what actually we can do, so we can actually, in the brute force approach, if I don't want to use the sliding window here, what is the brute force approach we can think that we will use like I know what is the window length, so I'll check that last 4 days and increase the frequency of each number. Suppose actually again x2, x3, x1. So I know our window length is 4 because from W I can easily check that what is the window length. This is 4. So what is the frequency of x2? That actually x2 is frequency is 1. Okay, what is the frequency of x1? That actually again 1. What is the frequency of x3? That is actually 2. Okay, so I'll check that all the frequency of all the all the numbers present in this window, it is less than equal to m or not. That means frequency of this x2, frequency of x1, I will check that this is less than equal to m or not. This frequency of x3 is less than equal to m or not. Correct. So if this is actually true, all actually true, then actually I can keep this item. Either I have to discard this current item, right? So this is the brute force approach. So what is the time series for this? Suppose we actually have this input array 1 2 3 4 5 6 7 8 9 10. Okay, so first of all W is suppose 4. Okay, W is 4. So this is one window because window length maximum 4. Right, now another window it will be this. Okay, next window it will be this, next window it will be this. Window length is 4 for this window. You can just say 1 2 3 4. Now go to the next window. This is the next window. All right, so next window will be this. So for, like, you can just see in the worst case, like for each I know what is the rightmost element. Suppose this is actually the ith day. I know this is actually the rightmost element of the current window. Okay, so I know window length. So what will be the leftmost window length or leftmost index of the window? I minus W plus 1. Suppose I is equal to 3. 0 1 2 3 4 5. Suppose 5. So I is equal to 5. Okay, so this is actually the rightmost index. I am assuming this is the rightmost index of the current window. So what is the leftmost index of the window? That will be I minus W plus 1. I is 5, W is 4 plus 1, that is 2. You can just see that for this window, you can see that our leftmost index is 2. This is our window. Got it? You can just see that I know window length is 4. So you can also cross check 2 3 4 5. Correct. 5 actually I assume this is the rightmost index. 5 is the rightmost index. Okay, next is 4 3 2. Got it? 4 element is present to create a window of 4 length. Now I can easily check what is the frequency of each number. I can actually easily iterate that. I can actually iterate the W numbers in the left side. So for that, for each index, I actually iterate W times to calculate the frequency of each number and check that all the frequency of this number is less than equal to M or not. So if it is less than M, I have to discard this. If it is less than M, then I can actually keep this current item. If it is greater than M, so I have to discard this current element. Correct? So to check that, I need to know the frequency of all the numbers. So that's why I have to iterate the W numbers, because this is actually the the window length W. So time of will be n cross W. Alright, clear? So this actually give us a TLE because n here actually length is 10 to the power 5. You can just see that n, the range of n actually is arrayable length is 10 to the power 5. Arrayable length is the n. Now how to optimize this? You can just see the actual sliding window. So suppose I have already explored this window. Okay, for window length is 4. So I know that which number actually I have discarded and which number actually I have kept, right? So suppose this is suppose x1, x2, x3, again x1. Okay. Now next number it is actually coming as x5. Okay, and W is 4. Now when actually adding a new number into the window, I know that one number will be removed from the window. Alright, because we have to adjust the window length. I know window length is fixed W. Alright, length is W. So if I actually adding one number into the window, so I know that whatever the number is present here or the leftmost, that will be actually now gone, will be removed from the window, because window length is sliding window, right? 4 length. If actually adding one new number, so length is fixed is 4. So whatever the number is present at the front or the left side, that will be removed from the window. Clear? Now when actually removing from the window, what actually I have to adjust? I have to adjust the frequency, because ultimately what you're trying to check the frequency of all the numbers. So I'll check the whatever number actually going to remove, like x1 will be removed. When actually adding x5, x1 will be removed, right? So I will actually decrease the frequency of x1 by 1, correct? Minus. Why actually this is clear? Why actually I'm decreasing the frequency of x1? Because this is now going to remove from the window. To adjust the frequency, ultimately I want to know the frequency of now this window. This x1 is now removed, so that's why I have to adjust that. So that's why I just decrease the frequency of it. Whenever actually adding a new number, that means x5, so frequency of x5 will be increased by 1. Clear? This is clear. Now when actually I have to discard, I have to check that whatever number is going to add x5, I have to check that what are the frequency of this x5, is it greater than m? If it is greater than m, then actually I have to discard this current type or current number present in the current day, ith day. So that time our answer will be increased by 1 if it is frequency of x5 is greater than m, correct? And to know that, because I've already discarded this item, that means this number will be not added into the frequency, right? This will not be added into the frequency because I have already discarded this item. So that means ultimately this is not present in the window. Alright. Suppose I have already removed x5. So that means our window it will present at x2, x3, x4. x5 will be empty. Alright. Now suppose I am going to add x6. Alright. Now frequency of x2 is when it will be decreased by -1. It is now going to remove from our window. This is clear. Now x6 is going to add into a window. This is clear. So when I'm going to remove x2, I need to know that is it actually present or not. I know this is present in the input array, but this is actually present in the window or not, that we should know. So for that I actually need one more array to indicate the true or false. True indicates that it is actually discarded, and false means it is actually present. You can use any way. Something you need to know that this is actually present or not, like it is actually discarded or not. We need to know that, because this is clear. I actually need to know that because when actually going to remove from the window, I need to adjust the frequency. To adjust the frequency, we need to know that this number is actually present or not. Have I actually discarded this or not? Correct? This is clear. So that's why how can I actually use the sliding window here? That first of all I need one actually frequency of all the numbers. Alright, so I know this is a fixed number 0 to 10 to the power 5. Suppose it is initializes frequency of all the numbers 0. Okay, so now I need one more thing, that it indicates that this is discarded or not. Suppose this is false. False means this is not discarded. True means discarded. Suppose true means discarded. Okay. Now I initialize all false. Now I know our window. So we all know how to the sliding window is I less than n. So I'll check that window length, whatever the length of the window, is it greater than uh, equals to m. So that time I have to remove one number. So that time I'll check that is it actually discarded or not. If not discarded, the L, the leftmost index, the front, that will be removed from the current window. I will check that it is not discarded, that means this is false. So that time I have to adjust the frequency. So that time I actually increase the decrease the frequency of the nums of L by -1. Clear? Else I will not going to adjust the frequency because any usage is not counted in the frequency map because this is already discarded. Alright. Now I will actually check that this current number, because this current number is going to add into the current window. So that I actually need to check that can actually add this, can actually keep this, or I have to discard this. So what is the condition? I'll check that the frequency of the nums of R is greater than M. That time I will discard this. So answer plus plus. Got it? Answer plus plus. Else, this is one condition when actually frequency of the current number is greater than M. That time I will discard this. Else, and also yeah, that means this is going to discard this, and discarded this vector also we have to mark this R as true. That indicates that this current number is discarded. This is not counted in the frequency map. Else, that means we can actually keep this current item. So I'll actually frequency of current item is increased by 1. Clear? And ultimately go to the next index R plus plus. Clear? So ultimately after this sliding window, when actually we reach the end of the input array, whatever the answer variable actually it indicates that how much number I have to remove or I have to discard. Clear? So that time actually we can actually easily in linear time big of n, we can actually easily check, we can actually easily calculate that how much number I have to remove. Previously it was take actually n square almost. Now it will take big of n. Clear? So now go to the code. If you have any doubt, you will comment on that. If you have any suggestion, that also you can actually share. And if you found this logic or explanation useful, please like the video. Now go to code. So first of all, I need to one vector to count the frequency of all the numbers. So I know already that the range of numbers is 10 to the 5. Arrivals I, the type of this is 10 to the 5 maximum. So that's why 0 to 10 to the 5. But and initialize is 0. And this is number of days actually it is possible n. Arrivals dot size. Now for each number I need to know one more thing, that this number actually present or it will discarded. So that's why initialize not discarded, n is equal to false. Like n number is present, all actually initialize is false. True means this is discarded. Okay, you can actually use anyway. So here actually false means this is not discarded. Okay, so so now start answer variable is 0 and start iterating the input array. So while actually our I, whatever the value is, rightmost index is less than n, I will check. So we'll check that if a current window I greater than equals to w, that means our window length is w. Now that situation is only case while actually I have to adjust the window, because that means our leftmost element is going to remove from the window. So that's why what is the leftmost window, that will be I minus w. So I'll check that it is already discarded, that means not discarded is equal to true. Yes, I minus w. Just see what is the leftmost index, that will be I minus w. Why actually I minus w, not I minus w plus 1? Previously what actually explained, actually I have explained that time that actually with respect to current rightmost index, but it is already increased to the I plus 1. So that's why it will be only I minus w. Got it? Oh, so I'll check that it is equal to true. That means this is part of, this is not discarded. Not discarded, true means not discarded. Just see the actual variable also. Variable means not discarded. This is true. That means this is part of the window. this is actually kept. So I have to adjust the frequency that time. So I decrease the frequency of that number, whatever number actually present or type arrivals of I minus w minus minus. Okay. Else if it is false, that means this is already discarded. Now I know. Now we have to adjust the leftmost index. Now we have to adjust the rightmost index, right? That is going to actually insert into the current window. So first of all, find out what is the type of the current element is going to come or going to arrive. So first of all, check the frequency of the current type. It is greater than equals to m. That means this cannot be present into the window. So first of all, discard the current number. So that's why not discarded of I false. That means this is actually discarded. So that's why not discarded. So and also increase answer plus plus, because I am going to remove the current number. So that's why this is one more actually number going to remove. So that's why to count that I will actually do the answer plus plus. Else frequency I can actually accommodate this current element in the current window because the frequency is less than m. So that time increase the frequency of the current number and also mark this not discard the current number as true, means this is actually counted into the frequency. Just see that whenever actually increase the frequency, I am also marking this as true. That means this is actually counted into the window. Got it? Why actually need this? Because when actually going to remove from the window, that time I also need this because this is one more condition that this is actually discarded or not. If it is not discarded, that time actually I have to remove the frequency also. And for that simple case that I have just increase the next window I plus plus. Ultimately after iterating the input array, whatever the return answer I have written that. This answer indicates that when actually our frequency is in the current window is greater than equals to m, that time remove the current element and increase the frequency answer plus plus. Got it? So you can just hear that it is just running into the one time on the input array big of n. It will take big of n. Clear? So I have shared this code in the description. You can check that also. And thank you. Bye bye.